Hey students, this is lesson 5.1. For this lesson, we're going to learn about the rate of change in slope. And in particular, we are going to learn how to find the slope and know it as the ratio of rise to run or the ratio of vertical change to horizontal change. Go ahead and do this vocab. Important definition here to pay attention to. Okay, finding rate of change using a table. The table shows elevation of hang glider over time is the rate of change in elevation with respect to time constant. What does the rate of change represent? To figure that out, we just want to find out the difference in elevation with respect to time. And since time goes up by 1 hour each time, we can just figure out the difference in the elevation and see if it's a constant amount. So 360 minus 325, that's equal to 35. 325 minus 290 equals 35 also. And 290 minus 255 is equal to 35 also. So there is a constant decrease in elevation. So it's going down, and it's going down at a constant rate of 35 feet per minute. So since it's going down, we're going to represent this as a negative. So we're going to say negative 35 feet per 1 minute. That's our rate. All right. You try that. All right, to find the slope of a line on a graph, we're going to find the rise and the run and divide rise by run. Rise is the vertical change, run is the horizontal change, and that's what we need to find the slope. So let's just write that up here. Remember, it's rise divided by run. And to find the rise and run, we just need to find 2 points on the graph that seem to be right on the grid lines. That helps. And then we're just going to draw a line up and a line over. Since it's a straight line, it should have a constant rate of change. And we are going up 1, which is positive. So going up is a positive. And right 4, which is also a positive. And our rise is 1. And our run is 4. And if we wanted to write that as a decimal, we could. All right. On this one, this line is decreasing, and I'll show you how that works out. But it looks like dots go out right there. And I'm going right 1, down 1. So right 1 is a positive 2, and down 1 is a negative 1. So I'm going to represent these as rise over run. So my rise in this case is negative 1. And my run is 2. And then I'm going to divide those. And I get, you can either write it as a fraction negative 1/2 or as negative 0.5. All right, you try that. Another way to find the slope is using the slope formula. If you have 2 points on a line, then you can find the rise between those points by just subtracting the y-coordinates. So the difference between the y-coordinates is the rise, and the difference between the x-coordinate is the run. Go ahead and fill in your answers, 13 and 14 here. All right, so let's use that slope formula here. We're going to use these 2 points. And the slope formula looks like this. M is the letter we usually use for slope. Subtract the y coordinates to get the rise. Subtract the x coordinates to get the run. Let me label them here so we know. And it doesn't matter which one you pick for y2 and y1. Just make sure you do them in the same order. So let's say that's my x of 1. This is my x of 2. This is my y of 1. This is my y of 2. So I'm going to do 5 minus 2, subtracting my two y coordinates. And then I'm going to do 1 minus negative 3. And 5 minus 2 is 3. 1 minus negative 3 is 4. So 3/4 or 0.75 is my slope. All right, you try that. Okay, some unusual situations in finding slope occur when you have a horizontal or a vertical line. And what I want you to take note of here is that any point on this line that's vertical has an x-coordinate equal to 3. So this point, for example, this point right here is 3, 3. This point right here is 1, 3. I said that wrong, 3, 1. But the x-coordinate for every point on here, and we'll look at this one down here, that's 3, negative 1. So notice the x-coordinate is always 3. And remember also that if it's a vertical line, it's an undefined slope. So there really is no way to give a slope for this. And so we say the slope is undefined. And if you use the slope formula to find this, you'll see that just pick two of these points. So I'll pick that one and this one. So subtracting the y coordinates, I would do 3 minus negative 1 over 3 minus 3. And notice we get a situation where we're dividing by 0, and that is not going to work. Okay? Now, if we want to find the slope of a line that's horizontal, and one way I just think of this is it's a flat line, there's no slope, so the slope is 0. But if you were to label a couple points here, so this point is negative 1, negative 2, and this point is 2, negative 2. And if you take the y coordinates, negative 2 minus negative 2, and subtract the x coordinates, 2 minus negative 1, you end up with 0 over 3, and that's equal to 0. So it's 0 divided by something. So undefined slope if it's a vertical line, and the slope is 0 if it's a horizontal line. Go ahead, you try that. All right, a quick concept summary. Slope of lines. We're going to pick one of each of these descriptions for each of these. Go ahead and you try it first, and then you can check back with your answers. Okay, the last problem we did was a vertical line, and that had an undefined slope, so let's put that one there. Slope of 0 means it's completely flat. There's no slope. That would look like that one. A positive slope comes from a situation where as x increases, so does y. So the rise and the run are both positive. And a negative slope comes from a situation where it's dropping as the x values decrease. And that would be a negative slope. All right, go ahead and do the lesson check, and we'll talk about that next time we meet in class.